Hello, and welcome to this episode of the Carbon Insiders Live, brought to you by Click LCA. My name is Melina Zaharia. I will be your host today. And in this event today, we will talk about how to create EPDs for your luminaire products and how to decarbonize lighting. Today, I'm joined by Click LCA EPD consultant, Kaushik Kesavan. Nice to have you with us, Kaushik. Would you like to introduce yourself a little bit?
Yeah, of course. Thanks, Milna. Pleasure to be here. So I'm part of the EPD team here in Click LCA. I've been here a little over 3 years and counting, and worked on a lot of things over the past few years, starting with a few consulting projects to now working with our internal product team to develop the Luminaire EPD Generator. So here I am.
Nice to have you with us, Kaushik. And now let's drill down into what you can expect from today's session. We will talk about the impact of MEP systems. We'll talk about what are luminaires and how you can measure their impact, how you can create EPDs for the lighting industry using Click LCA's Luminaires EPD Generator, and then we'll have a product demo brought to you by Kaushik, where he's gonna walk you through the tool. And if we have time at the end, we will do a short Q&A. So if you have any questions about us today, please drop them in the comment section. Now let's begin. So I don't know if you know this, but construction and manufacturing account for 57% of global carbon emissions. So decarbonizing the built environment is really key to keeping the climate stable and reducing global carbon emissions. Now, speaking of the built environment and carbon emissions, let's dive into some of the highest emitters in buildings. And when we talk about highest emitters in buildings, we talk about MEP systems. MEP stands for mechanical, electrical, and plumbing systems. And it can account for up to 50% of embodied carbon in new buildings. And when we talk about embodied carbon of MEP and the impact of MEP, lighting units, which is a component of MEP systems, is considered a very high impact item and counts for a really big chunk of the overall carbon emissions related to them. As you can see here, throughout the whole life of a building, lighting accounts for up to 15% of global electricity consumption and 5% of global greenhouse gas emissions. And as you can see on the graph right here, that is provided by the Carbon Leadership Forum, the carbon of lighting and MEP systems is really consistent throughout the entire lifespan of a building. This is why reducing the carbon impact of MEP systems and lighting is really important. So what is a luminaire? We're talking about luminaires today. We have a Luminaires EPD generator. A luminaire, or a light fixture, as it is most commonly known in so many parts of the world, is an electric unit that provides illumination. And what makes the unit is that there are several different parts, not just a lamp. The word luminaire derives from the Latin word lumen, which means light. So why is it important to measure the environmental impact of a luminaire? And how you can actually do this? You might know the answer to this question, and if you don't, you probably have guessed it from the title of this webinar. And the answer is with an EPD. An EPD, which stands for an Environmental Product Declaration, is a document that transparently communicates the environmental performance or impact of any product throughout its lifetime. And within the construction industry, EPDs support carbon emission reduction by making it possible for professionals in the sector to compare the impacts of different materials and select the most sustainable option. An EPD, a third-party verified EPD document, is usually valid for 5 years and is generated according to relevant international regulations. And now I'm going to pass it over to Kaushik, and he can talk to you a bit more in detail about a product's life cycle and EPDs for lighting products.
Thanks, Milena. So when we talk about an EPD, it's definitely very important to understand all the life cycle stages and the scopes that go into making an EPD. Because as the first step, it's important to understand what's going to be included. Like in this case, I'll have highlighted all the steps that are going to be a part of the Luminaire EPD generator. And starting with the product stage, raw material supply. So right from extracting all the raw materials needed to make your luminaire, be it metals, plastics, or electronic components, to transporting them to your manufacturing site, where it's actually assembled and manufactured together, and then comes the construction process stage. So here it's transported to the customer's site, customer's location, where it's actually installed. Now, the installation phase can include any energy consumption as such, but it's often used done by hand, so it's not that important in this case. The next stage, the use stage, is actually one of the most important stages, as we'll see. So here I've highlighted B4 replacement and B6 operational energy. Replacement refers to all the stages that all the parts that may or may not go defective. In such cases, replacement is handy because let's say the LEDs don't work after a few years, and since the lifetime is often 20 to 25 years, it's required to actually have the whole fixture working up to your efficiency. So replacement comes in handy there, but it's not commonly used in the luminaire industry, at least not so far. And then the operational energy use, this is basically required for the product's functioning. So we'll see more about how impactful this is compared to the other life cycle stages soon enough. And finally, we have the end of life. Now, end of life here refers to deconstructing the product from the building itself, transporting it to the waste processing facility, and may go through recycling, incineration, landfilling, any of the options. And what I've understood from my experience working on luminaire EPDs is that half the time often goes on just the end of life stage modeling compared to half the time of the total EPD making process. So, and what this luminaire EPD generator does, as you'll see, is that is completely automated. All you'll have to do is choose from a drop-down which process you would want for a particular material or an electronic component, and voila, there we go. That's completely done. It's as simple as that. We'll see more about that in the upcoming demo, but just wanted to mention that the end of life stage, one of the most crucial ones, is fully automated here. But why do we have to actually create luminaire EPDs, right? Let's dive a bit into that. So when we look at the European market, there are more than 50 million stock keeping units or variations of the product for MEPs in the European market. But when you look at the amount of EPDs out there, it's just less than 20,000. It's such a huge discrepancy in the numbers that we felt that having this generator would definitely help at least push for this discrepancy, trying to bridge the gap in a way so that these numbers are closer to each other. We'll also see how quickly and how efficient this process is in a while. And as users, you may have understood the complexity that goes into modeling a luminaire, but there's also the challenges such as your suppliers, your clients might often ask for environmental data, and it's often not that easy to get it. And this EPD helps to transparently communicate these benefits and also accurately showcase these, because an EPD is third-party verified after all. There's also the regulatory demand, because in the construction industry, there are so many kind of regulations coming into place, especially in Europe over the last few years, and EPDs help bridge this gap as well. So, like I said earlier, one of the major contributors to the environmental impact of luminaires is B6, the operational energy use phase. So it's typical that of almost 90% of the total impact of the life cycle comes from just this one stage. Now, this is not to say that all the other stages are not important. It's definitely needed. In fact, it's actually more important than B6, because all eco-design principles that you may have been implementing in your supply chain, in your manufacturing site, and your R&D team, all of this comes into play in A1 to A3, where the product is manufactured, to lead to more efficient energy consumption during the use phase. And this can be through electronics. So A1 is, like I've highlighted here, it's a small chunk, less than 10%, but that can contribute in a big way to optimizing B6. And this can be from LEDs, PCBs, or the batteries, as we've seen, but also like the fixture materials themselves, which are often made of metals and plastics. Now, coming to the challenges in measuring the impact, it's often that luminaires have such a diverse set of materials in them, right from, like we saw in the earlier slide, metals, plastics, and electronics, that the supply chain itself becomes a bit convoluted. Like there are so many different suppliers out there from different parts of the world with different carbon footprints, and it's sometimes a bit messy, to be honest. So I think the data availability becomes a problem as well, because data collection is often one of the more important parts of the EPD generation and one of the most time consuming. So the end of life management, when we look at that, like we saw earlier, is fully automated. One reason for that is because clients often don't know what happens in 20 to 25 years down the line. So here, in this case, we use specific standards like EN 50693 in this case, so that there are specific processing methods in place, and we use those specific data points as well to automate this part of the life cycle.
Thank you, Kaushik. That was really insightful. It's really interesting to see all the challenges in creating a luminaire EPDs, because as we said, luminaire is a lighting unit. It consists of many different materials, and the biggest challenges is exactly that. We have different suppliers from all around the world that have different specifications, different requirements, and they don't have to abide to the same standards. So it's really important to find a way to, as you said, measure and calculate all these different components. But when we talked about the challenges, now let's jump into the benefits of creating EPDs for your luminaire products. There are many, many benefits of creating luminaires. However, I'm going to focus on the two biggest ones. You get to decarbonize lighting and your lighting products. By getting consistent carbon data for all your products and all your sites, manufacturing sites, you're able to then create really reliable EPD documents that help you benchmark your product against competitors. And that also help you discover hotspots in your product's carbon footprint. You're able to see which processes create more emissions and optimize them. And number two, something that is relevant and really important for everyone, because many companies have to create more and more EPDs, is that you get to win more business by creating EPDs for your luminaire products. And why is that? Is because by creating EPDs, you get to comply with increasing embodied carbon regulations that are coming very, very strong in many parts of the world, globally, not just in Europe, in the US, in Australia. And also you get to gain accreditation and green certification and schemes and EPD documents, especially third-party verified, are important to gain these accreditations. And also, by having a document with all this really reliable carbon data for your product, you actually help your clients, because they also have their own carbon commitments. Most of your products in Europe and in the US right now demand transparency when it comes to the carbon footprint of your products. So it's really important, and having an EPD really can differentiate your product from your competitor and help you win more contracts in the end. So now I will pass this over again to Kaushik, and he can talk a little bit more in detail, and he can introduce you likely to the Luminaire EPD Generator before we move on to the demo section of this episode. Over to you, Kaushik.
Thanks, Melina. So when we say this Luminaire EPD Generator, when we talk about it, it's actually end-to-end verified. And what that actually means is that with the program operator EPD Hub, in this case, the tool has been completely verified. So all the possible changes that a user can do has been verified, meaning the user can change only a limited part of the tool and the rest is automated. So that way, both the user and the verification process win in this process, and the whole thing is more streamlined. So when we talk about end-to-end verified tools, it's usually product specific. Now, the Luminaire generator is one of the first that we have for this kind of end-to-end verified tool. It's automated and optimized in such a way that there's very less work required from the user's side, as we'll see. And since it's already verified with EPD Hub, it also leads to quite a number of key features and benefits, which we'll come to in just a bit. There's also consistency in quality and transparency, because there's no longer a problem of whether a particular user, particular manufacturer is following a certain end-of-life stage to model their products. Might be that some want a 95% recycle rate, some want 100. Now that discrepancy can be removed because the end of life here is based on a specific standard. So that way we can avoid any chances of error. And it's all comparable in a way because of that as well. And the EPDs coming out of this generator would be compliant with EN 15804 as well as ISO 14025. The former being for the EPD standard, and for ISO 14025 is the standard for third-party verification as such. So let's dive into the key features now. So like I said earlier, this tool is specifically for light fixtures, and there are a bunch of data that comes along with it for the user to use. So it's also restricted in such a way that it's not that any and all data can be used. You also have to have the data verified beforehand with EPD Hub so that the program operator understands why you require this data point and how it feeds into your own product for the modeling. Maybe there's a better data point out there, right? So such suggestions can also come in handy for optimizing and modeling accurately. There's also a ready-to-use EPD template that Click LCA provides here, and that can act as an example luminaire for you to know the key features of the tool itself, but also to understand how you can model your own product. The third one, load verified manufacturing site data. So this one is one of our newer features, and it helps to include all the data from your manufacturing site, like ancillaries, packaging, energy use. All of this can be entered as once on the factory level, and then the software changes it to the declared unit level when you have to reuse it for all the products manufactured in that site. There's also the integrated EPD publishing. So like we said, the tool is verified with EPD Hub, and this ensures that you get a lot of third-party verified EPDs in a short amount of time. I'll talk a bit about how that happens. So the first 3 EPDs go through the regular verification process with EPD Hub, so they're manually verified. But after the first 3, it happens in such a way that since this is end-to-end verified, on all the data has to be verified beforehand as well, that there is less work for the program operator, less changes for the program operator to monitor. In such a way, after the first 3 EPDs, all the subsequent EPDs are automatically verified and published. And when we look at the training that Click LCA offers for this tool, it's also that we have a specific course designated to help the users succeed. And of course, like I said, the tool is compliant with 15804 and 14025 as well.
Thank you, Kaushik. I have a question to understand something a little bit better. You mentioned automated verification and publishing. After the first 3 EPDs, I'm wondering if only the first 3 EPDs are verified manually by EPD Hub, then how is the quality of the next EPDs also guaranteed?
That is a good one. Thanks for pointing that out, Melina. So when we look at the whole scope of a manufacturer publishing EPDs, it's that there's also a sample verification taking place from EPD Hub site every month or a yearly basis. So the way this works is that 10 to 20% of all EPDs published automatically will go through actual verification process. Like let's say there are 10 EPDs published automatically, one of them would be manually verified. And if there are some errors found in that EPD, of course, it would lead like a cascading effect to all the other EPDs that are published as well. And that's how we catch errors and make sure things are the way things have to be.
Thank you. That clarifies it quite a bit.
All right. So the workflow, the usage of the tool is quite simple, actually, and it's just a simple 4-step process. So for many of those who have been using our tools and are familiar with EPDs, you will know that the first step, gathering the bill of materials for your product, is often one of the most time-consuming areas in the EPD workflow. And once you do that, the data points that you use will be verified with EPD Hub. And after that point, it's just a matter of entering all of this in the import form. We recommend the import form highly, but because it's more flexible, it gives you the options to work on a lot of things in an easy manner, but there is also the possibility to work on it directly on the software. But if you use the import form, the next step is to import the Excel file into the software. And finally, it's up to the user, up to you, to make some final checks to ensure that all the data that you bring to the table is good and the data points you've chosen are, the way you want them to be. And the last step would be submitting to EPD Hub. All right, so that would be about the presentation. Let's jump into the software demo to see how the tool looks and how it can help you. Let me share my screen quickly. All right, so assuming you can see my screen.
Yes, we can, Kaushik.
Thank you. So this is the project page. For those who are familiar with our software already, you might know this does not change too much. But for those who are not aware, this is the project page. Now, I've chosen the Luminaire EPD Generator as the tool to be used here. And I have a test design here for me to work on. And I'll take you through those. So we have the manufacturer and site information to begin with. This query structure is slightly different to the way things are. As you might see, the number of tabs on the top are a few bits lesser. 2 sections have disappeared because they're automated. We'll go through one of each of these now. So the first manufacturer and site, we have all the manufacturer's information like the name, address, email, and all of this will be populated in the EPD report, which we'll also see at the end of this demo. There's also the site information, the country and the city where the production facility is based, and the period the data represents. Now, this is very important because this depends completely and this influences your manufacturing site data. So this can be for energy, for example, or ancillaries and so on. And it's important that all the data that you use from your factory is from the same year. The next tab, product specification. Here we go into a bit of a more detail on the product specific description. So here I'm just describing what a lighting unit is. So it's a very simple definition of a luminaire, but you can also have more information here on technical specifications of the product and any other information like the standards the product complies with within the industry and so on. Characteristics, this is important as well. And this is mandated because this forms the basis for comparison when a client or a user looks at the published EPD. This is what stands out as a means of comparison as well. So here, for example, we declare the operating voltage, temperature, there's the production index information as well, luminous flux. Here it's taken it to be 8,000 lumens, luminous efficiency, and the electrical power finally. If there are any additional characteristics that are not visible here, you can add them here. This can be, for example, if you have a different lens type that I've come across in a few cases, then you can add that information here and what the product you're doing the EPD for represents. It could also be for the installation fixture. So some are suspended from the ceiling, some are just fixed statically. So all of this can be mentioned here. Then we move on to the raw material composition. So as EPD Hub goes, there are 5 different categories that are required for this tool. 4 of these are as with any other tool, but the next one, electronic parts, this is required specifically for the luminaires because it helps it stand out to see what percentage of the mass comes from just the electronic components. Because like we saw earlier, the impact comes first from energy consumption and second is the electronic components. So it's important to see how it influences. There's also the biogenic carbon content. So this leads to any bio-based materials in the product that you may have, or bio-based plastics as well, or in this case, the packaging. And any REACH materials that you may have. So this refers to the substances of very high concern that are above 1,000 parts per million in your product. If that is the case, then you declare them here. And this is as required by 15804 standard as well. Then moving on to the next part, materials and manufacturing. Now this is where the magic happens and all the fun. So let's look at this part. So declared unit. It's often one unit because that's what we are looking at when we say a luminaire. We're not looking at 1 kilogram of a luminaire. That's just, confusing. So 1 unit it is. Mass of the declared unit. This refers to the mass of the product itself. In this case, I've taken an example of 5.5 kilograms with a packaging weight of 0.268 kilograms. The functional unit, this is mandatory whenever we have a use phase as such. So here I've taken 1,000 lumens and 35,000 hours as the base, because from what I've seen, there are in the industry, in the lighting industry, it's often common to show the impacts for this specific dimension. So for 1,000 lumens and for 35,000 hours, because the product that we are modeling is going to be more than this. Like we saw in the previous stage, the characteristics show that this product is for 8,000 lumens, and that's not, and some other products may have like 12,000 or even 20,000 lumens. So it's not directly compatible in such cases. So to make the results compatible, results at the functional unit level is important, which is why we have 1,000 lumens as a base for comparison, as well as 35,000 hours fixed. Now, what the software does in the background is it would convert the results to this specification as well as the declared unit level, so that it's a bit easy and you have both the results at hand. The reference service life, 20 years. As an example here, it can depend on a lot of factors and the application, be it its need in warehouses or sports facilities, and so on. Assigned lifetime is 50,000 hours here. So, materials A1 section. So this is officially where the modeling begins. So for those who are familiar with the software, it's pretty simple, pretty similar to how we have it earlier. There is one thing at the end that I'll come to, but we have the resource here, the quantity, and then the comment for you to enter any information you have. Now, this is specifically important because I've noticed that I often miss information on how I've modeled certain things, and it becomes important. So if I open the sensor here, for example, this is by dismantling a particular sensor that we've obtained the information. So, and we saw the polycarbonate, the printed wiring board, and the cables, weight, or so on. But for certain materials like the cable here, its unit is in meters. So it's important then to understand how we obtain 0.02 meters. If I didn't measure it, it's going to be hard. And here we need the weight of 1 meter of cable as well. So you can add more information here if you require, and it also helps the verification process since it's all in one place. Then there's the classification. This comes in handy in the results page for classification of the results, the graphs, and the pie charts. Helps to group impacts together based on the information we've given here. Then we have the transport distances for leg 1 and leg 2, and the method that is available. Here it's a 32 metric ton lorry that I've used. And then there's also the recycled material, if any, that you've used in your product, and for a specific material. By default, it's 0. And finally, we come to the end of life scenario. So like I said, this often takes, we used to have a separate tab on the software for just calculating the end of life. And there was a lot of calculations in the background that had to be done before it feeds into the software. But all of this can be avoided here because all you have to do, choose which end of life scenario is applicable for a particular material or electronic component. So I have end of life for paint, end of life for copper, glass, and as well as plastics. So everything is in one place in this tool. So it becomes very easy, and you just choose from a drop down. And then when we go down, we have the other sections, manufacturing. So in this case, it's energy. So energy that goes in the manufacturing facility, let's say to assemble the product, or if you manufacture any components yourself, that would go in here as well. So here I have diesel, natural gas, and grid electricity. Of course, this would depend on your specific case. And then there's also the production loss. So steel production, hot rolling, metalworking, and so on. Packaging film, we have the cardboard as well as wood pallet, which is one of the more common types of packaging used for transporting luminaires. And finally, we have ancillary materials. In this case, I have lubricating oil and water use. So something that I would like to point out here is the manufacturing site data. That's important. So here we have the manufacturing site, I have made an example site here where with all the required information, and once we have all of this information, so for the energy consumption, it's already filled in here, and this all the quantities are at the factory level. So in a year, this product line consumes 100,000 kilowatt hours of electricity, and the resource use for manufacturing waste and as well as ancillary and packaging. So I've entered all of this on the level of the factory. And what we want to do here is we want all of this information at the product level. So the factory level data comes in handy. So I choose whether it's mass allocation. Now it's locked here because it's been verified as a site data by EPD Hub, so I cannot edit this here. But this dropdown would show you the allocation options. And I've chosen mass allocation as the most representative for a luminaire. So finally, we choose which tools I want this site to be valid for. And once this is created, I'll quickly show how this works. Maybe right here. So when I come all the way up here, I have import data. I have load site data. So now this dropdown will show me only the site information that is verified beforehand. I have two sites. The one I want is site X 2023, and then it asks for the mass of declared unit. Now this is required, like I said, to convert the data from the factory level to the declared unit level. So the mass of the product is 5.5. I enter that and I load site, load data, and it's going to populate all of the information for manufacturing, energy, ancillary, and packaging. Now I don't want to do that here because I already have information here added manually. So I'll just stick to what I have here. But this comes in very handy because you don't have to enter all of these manually, and it's going to be the same. It's going to be scaled to your product's weight automatically as well. And then we move to the transport to the building site. Here we have it's a bit more simplified than how things were in the normal tool. I'll say that as well, because earlier you had to enter the quantity, the distance, as well as the resource. But here the quantity is just not shown. It's automated in the background. So let's call it semi-automated. Here you just have to enter the transport method. I've chosen a lorry to transport to the customer's location over a distance of 1,000 kilometers. And it's often based on average sales data on all the countries, all the locations that you sell to. And an average of that is to be made. But here I've assumed it to be 1,000. Installation into the building, A5. Now, like I said, this would be about energy consumption during the installation of the product in the factory. Any information such as like the hand tools, drilling, screwdriving, and so on that is going in to make the product fixed. Here, it's just assumed to be negligible because assuming it's done by hand, so no energy. Going to the next tab, use stage. So operational energy use. Now here I've chosen the grid electricity mix at the European level. So this is as an example, but it's often required to show the electricity at the country level where the product is present. So if you sell for, let's say, 3 countries in the Nordics, Finland, Sweden, and Norway, as an example, then you're going to have to show those 3 countries specific data points, so 3 different rows here. And you would have to split this quantity based on your average sales volume. So if 50% goes to, let's say, Finland, you'd have 50% of the total quantity allocated to that particular data point, and so on. So that would be the best and most efficient way. And that brings us to the end of the modeling itself. And then it's the EPD generation page. We choose the brand image for your company, the product image for your product. And then we have the EPD author and organization, the reference standard, and finally, what category of the EPD is. So all of these are the possible options for publishing with EPD Hub. And since the tool is verified with this program operator, these are the options we have. Third-party verified, the most common ones, so I'm sticking to that. And finally, when we go to the results section, we have the default format. So we have all the results for the different impact categories that we require. So for each of the life cycle stages on the left, and on the right, I have each of the indicators. So here is GWP total, GWP fossil, biogenic, acidification, and so on. So all the results will be translated into the EPD document automatically, but just to show you how it looks like, here they are. Then moving down, I have the most contributing materials. Now, this is particularly important for R&D purposes or if for eco-design practices. So to understand where most of your impact is coming from, this section is handy. So I have the light emitting diode at the top right now, but you might be wondering why this is the case. Wasn't it operational energy that was contributing the most to the life cycle? But it is true, it is still B6 that is contributing the most. But in this case, we are looking at impacts for your product. So it's only A1 to A3 stages included in this analysis. And yeah, all the information along with the percentage of the impact are shown right here. And then we have a lot of different graphs types. So there's pie charts on the life cycle stages, the classifications. It can be as a bubble, Sankey diagram, tree map, based on the life cycle stages, a lot of different variations. So that would be actually all about this tool that you would require to know about. Honestly, yeah, it saved me so much time when using this tool for my consulting projects. And yeah, this would be the norm going ahead, and I'm excited about it going forward. Back to you, Melina.
Thank you, Kaushik. That was really useful. And I would like here to point out something that maybe also it took me a while to understand when I was first learning the tool, that when we talk about the site manufacturing data that then we can load directly into the tool, it's something that you can do from your account, from user account. So you can do it before you start using generating an EPD, right?
Definitely. Yeah, it's often handy to do that beforehand so that you have your site data all set up, and then all you have to do is import it into your design.
Perfect. Thank you, Kaushik. This is really, really, really insightful. I hope that everyone enjoyed this demo. And now, before we move on, I would like to give our audience the opportunity to, if they don't know already, to learn a bit more about Click LCA, which is Click LCA is a world-leading end-to-end sustainability software for construction and manufacturing, with an experience of over 20 years in the sector. With our tools, you can comply with more than 80 national regulations and standards, while you get access to the world's largest construction LCA dataset. The software also supports more than 20 BIM and other integrations, and you may learn more about Click LCA and all the various tools that we offer at oneclicklca.com. And while talking about Click LCA and their tools and today's subject, the Luminaires EPD Generator is a perfect tool for lighting manufacturers because they can create simplified LCAs for sustainable lighting and generate third-party verified environmental product declarations that allow them to create low-carbon products, differentiate their product, and comply with global regulations. So if you are interested in our experts contacting you and booking a demo so that you can take a closer look at our tool, now you can click yes to the poll that you see displayed on the screen, and one of our EPD experts is going to contact you, and you'll get the opportunity to actually see the tool in action. And now I would like finally to make an honorable mention to Academy. Academy, if you don't know about it, is brought by Click LCA, is a space where professionals in the AC and manufacturing sector can come and learn more about LCA and EPDs. It is a free training program, and it's part of Click LCA's commitment to train over 1 million low-carbon experts by 2030. In Academy, you may find dozens of courses and on-demand courses about EPDs and LCAs, or you can join one of our live bootcamps. And here we would have a Q&A section. However, I don't believe that we have enough time to go over. So we're going to skip it today. If you have any more questions, however, you can contact our experts, and you can email sales@oneclicklca.com, and you can ask them everything that has to do with Luminaires EPD Generator or any other tool that you might be interested. It was lovely having you all today, and I hope you learned a bit more about luminaires and the importance of creating environmental product declarations and reducing their carbon impact of MEP systems. Lovely to have you with us, Kaushik. Thank you for joining me today.
Thank you.
And have everyone a lovely day and enjoy the rest of your week. Bye, everyone.